Okay. Seem to have audio? No? Good evening, everyone. How's the connection? I've got chat working, so by all means, please let me know if everything's working properly. And tonight, it's Glacier travel. There we go. Okay. 7:30. Made it. Okay, let's see. Okay. Everyone can hear me? Sounds good? A-okay? Perfect. Thanks, guys. So I'm just going to give it a minute or two. I would have liked to have started a little bit sooner. It's been a busy day. Well, I sit in my closet and talk to a small black box. I'm going to need some counseling by the end of this pandemic. Okay, let's see. All right. Shall we get going? We've got 50 people on tonight. That's great, thanks. All right, so this is basically information that is available from a book that I haven't finished yet. It started shortly after the pandemic began, and I've been working on it, and this is kind of a tightened, abridged version. And basically it's looking at glacier travel and crevasse rescue. And the reason I wanted to do basically a book on this is because we have a standard for glacier travel and crevasse rescue for guides. We have to be able to work at a certain standard and be trained to do rescue to basically the best practices we currently have in the industry. But we don't have anything like that for the public. And there's really no point in teaching advanced crevasse rescue for most public uses because it's far more complicated than what most people are ever going to need. But at the same time, we do need to have a good system because when I was talking with some of the park rangers and park wardens, they were actually telling me that there's quite a significant number of people who call for rescue when someone falls in a crevasse, when they're roped, because they're able to arrest the fall and hold the person, but they can't get them out. And so clearly we're not working with something that works as well as we like to think it does. And then the other issue is working with other guides. We have a standard that guides are trained to, but we don't have a standard that we teach. And so one organization can teach very differently from another organization. And if you get people who've taken different courses on the same rope, they're not going to have the same ideas on how to get somebody out. And so that creates a real issue in terms of safety and effectively getting somebody out of a crevasse. And so about maybe a year and a half ago, I can't remember now, I contacted the technical director with the Association of Canadian Mountain Guides, and I suggested that I was going to work on a standard for the public. And he liked the idea, and the ACMG agreed to assist me with helping define the standards. And so that'll be the next step, is taking what I've got and giving it to them. But beyond that, within the Alpine Club of Canada, I work for the ACC as their lead winter guide. We are setting a standard that we now teach, and we'll want to encourage the other clubs and sections to work with as well, because we want to have a standardized system based on basically the best techniques we can. So that's what we have here. And this is not the whole book, it's not even close, but it's a few points because, to be honest, to try and do a course on crevasse rescue in an hour would be just evil. All right, so let's get started. And I got to switch audio here, so just hang on a sec. All right. So glaciers are pretty amazing, and the best time to travel on them is winter because it's just so much easier. We do travel in summer as well for doing alpine approaches and climbs, and people even do things like the Wapta in the summer as well. Um, it doesn't matter. It's the same techniques, it's the same skills applied. But, we're heading into winter, and this really is when we start thinking because it's just so fun to move on skis. Yes, you can go on snowshoes, but they're not fun on a glacier. That's why we're all ski guides. And what I'm going to show you is based on the idea of a minimum of 3 people on the rope. And that's kind of the standard we're starting with. For the simple reason that 2 people on a rope, when one person falls in, that is tough. It is very difficult to hold that one person, and it is not a simple process to get them out of a crevasse. And so until you're pretty comfortable moving on a glacier and working with a team of 3 and you know the basic system, we're really not recommending people travel as just parties of 2. When I was training to become a guide, we would practice with these systems and we'd find slopes where one person could jump off the edge and there was a soft landing or a good ramp at the bottom, so that if things didn't work, you didn't actually kill anybody. But then someone else would be tied on the other end, and sometimes it was me. And when that person jumped off the edge, it was shocking just how far we got dragged and how much it hurt to try and stop one person on a rope all by yourself. And then you have to hold that person while the weight is literally cutting you in half, build an anchor, and then go through the rest of the motion. So we're starting off by saying travel in teams of 3 or more. And once you get comfortable with that and you build your skills, then you're in a much better position to be able to develop the skills to work with a single person. Okay? I think that makes sense. All right. And I guess the first thing you want to think about when you're going on a glacier is when do you even put the rope on? And this is surprisingly often sort of overlooked, or we don't think about it quite so much, or we struggle with it. And the bottom line is if you're ever uncertain, put the rope on. Okay? It's that simple. If you're having limited visibility, it can be really hard to see the slots or concerns, put the rope on. If the snow cover is thin or variable, it's far too easy to miss something and get surprised. Put the rope on. If you can see the landscape and you're seeing sags or crevasses, they're visible, put the rope on at least until you get more information. Putting the rope on should be your default position. Simple. No issues there. And in terms of how deep is deep enough for a glacier, that's not a solid rule. But if you're consistently seeing depths of over 2 meters on the glacier, and the crevasses, like it's not a huge glacier with massive slots, that may be acceptable if you're getting even coverage. But it's going to take some time, and you're going to have to probe to be able to tell. And so you may initially start with the rope and change your mind if everything else looks good. But you do need a probe, especially this time of year, because the snowpack is thin and you may not see a sag. One of my mentors went into a crevasse not too long ago, and he'd been traveling on glaciers for over 40 years. So it is possible to hide a crevasse in relatively little snow. Put the rope on, probe, get the information. If you're getting good information over a long period of time, then maybe it's appropriate to take the rope off. If everything else is good, you can see you've got great depths and there are no concerns. And then when you get to the height of land, you get to the dips, you get to the windward side, they're all giving you deep depths, maybe. But if in doubt or there's any uncertainty, keep the rope on. Because if you fall into a crevasse with a rope on, we go into basic rescue. If you fall into a crevasse without a rope on, there's a real chance you're not going to survive. Forget a rescue, you may not survive the fall. And if you do survive the fall, you're going to be begging that there's a big bench and a partially filled crevasse at the bottom, because if there isn't, you're going to wedge into one side of the ice or the other. And when that happens, your team can't get you out. They're going to have to call for a rescue. Park wardens are going to come in, or park rangers, or search and rescue teams, and they're literally going to have to chisel you free from the ice and pop you free and then winch you out. Your odds of survival are really low. With a rope on, traveling on a glacier, traveling through a crevasse field is actually a relatively reasonable probability you're going to go in, but a very low probability of being injured. And to be honest, I'm much more comfortable going through crevasses than I am going through avalanche terrain. Because when I get it wrong, so long as I have a competent team and the rope is on, it really is a low consequence event if you're doing it right. So don't be afraid of crevasses, don't be afraid of glaciers. But if you're taking the rope off, then you can be afraid. Keep it in that mind. Put the rope on and sure, it might feel scary, but now you've got a margin. And probe. Probe constantly until you get lots of good information. That can take half an hour or a couple of hours before you really get a handle on something, depending on how well you know the area. So that makes sense. Now, we've changed some of the standards for how much space there should be between you on a rope. And this is the measurement for a 3-person rope team. We now say you should have 10 meters between each person in summer and 12 meters between each person in winter. All right. So this way you have time. If somebody falls in a crevasse, you have a situation where things give the people on the surface time to basically catch you. And they're going to get dragged a bit. That's okay. You've got room. Slows down, comes to a stop, you're all right. So we recommend these as minimum numbers. If you want to add to that because the terrain's bigger or you have concerns, then by all means, you can add to it. But again, in summer, you probably want 10 meters between each person. In winter, you want a minimum of 12. And also keep in mind, if you're a rope team of 3, you also want to balance your weights out a bit. You don't want a rope team where one person weighs, well over 100 kilograms before they put the gear on, and then you've got 2 people in behind that weigh less than 100 kilograms each. That's a huge mass in difference. You want rope teams where people have reasonably similar strength and weight comparisons. Much, much easier to hold. Okay? So there are a few things. Now when you get the rope, for a 3-person rope team where you can switch back and forth, so the first person leads and when they get tired, they stop and then the end swings around and they lead, you're going to need to break the rope down so that you have some rope in your pack for rescue. You have to have some rescue rope in your pack if you want to get somebody out of a crevasse. That's either coils from your main line or it's a second rope. Personally, I like to use one rope. Life is better for me. If you want to carry a second rope, you can. But basically, you're just going to tie it in as if you're extending the original rope anyways. So let's take a look at how you measure a rope. So you're going to need 60 meters of rope for 3 people doing glacier travel where the front and the back can both lead. And now there's lots of different ways to measure the rope out, but this is probably the easiest and the most efficient. Literally just count the number of pulls between your arms and then measure that distance, and you have a sense of what you're doing. So I've got a 60-meter rope, and I can tell you right now, I pull 33. So you divide that, and that works out to about 1.8 meters per pull. And so if I want 12 meters between me in winter, I'm going to pull 6.5 cords, or 6.5 lengths. And that's my space between each person. But before I do that, I need to set aside that distance in the pack. So I need to pull 12 meters or 6.5 pulls to put in the pack, because you want as much rescue rope as there is space between people. Okay, so I counted 6, probably should have done 6.5. And then when you tie the rope off for the first person to clip in, you can tie an figure 8, that's fine. But I just tie an overhand. And that's the knot I teach because it's simple. And simple is good. One of the things we're really trying to do with crevasse rescue is create the simplest systems possible, because once we start getting into mechanical advantage and other systems, it becomes complicated. And you have to remember this system, at the end of a day, 3 years after taking the course, when you're exhausted and the weather's bad. So simple is good. Now I'm measuring 6 pulls in between, but I added 4 more pulls. 2 more pulls, because I need another 4 meters for the knots I'm going to tie in between each person on the rope. And we call these moose knuckles. Moose knuckles are relatively new in Canada and North America, but they've been around in Europe for a long time. They use a slightly different knot. I can't remember what it's called, but in Canada they just thought we'd try something a little different because we thought it was easier. And each moose knuckle takes about a meter of rope. So with 4 moose knuckles between each person, you're going to need basically an extra 4 meters of rope, which is 2 pulls. Get to the second person, tie it off. There we go. And I mark that by just pushing it out on the snow so I know where it is. It was a bit of a windy day. Okay, so there's the second. And I measure 1. And I do 6 little pulls for the 12 meters. But because of the moose knuckles, I throw in 2 more pulls for a total of 8. Oh, I was ahead of myself there. That was the third tie-in. And so I know I've got more than 6. And so you can see there, we've tied the knots on the rope. And a moose knuckle is just a modified variation of an overhand knot. I don't have a video for it, but I do have a still coming up shortly. And so the moose knuckles are tied 3 meters out from each person towards the other, and then a second moose knuckle 2 meters past the first. And so there's 4 moose knuckles between each person on the team. And the idea behind the moose knuckle is if somebody falls into a crevasse, the moose knuckles will get buried in the snow and they'll create friction. Now, if you're curious about this, do a search. I don't have the link handy. I can look it up. But group of French researchers were doing tests where they dropped people, or basically they dropped an 80-kilogram load into a crevasse, and then they basically had a scale on the other end to measure the weight or the force of the rope as it cut through the snow and what it took to hold that falling weight. The initial shock between a person on a regular rope and a person on a rope with moose knuckles was about the same. But as the rope cut into the snow, it absorbed huge amounts of energy, and it became much easier to hold someone who'd fallen into a crevasse if you had moose knuckles. And so for rope teams of 3, we strongly recommend using them now because they will greatly reduce the force, and once they set, they will almost hold the person in the crevasse. So it's a lot easier when you're on the surface trying to keep someone from falling in to hold them in place. So if you're a team of 3, we strongly recommend them. And for a team of 2, it should be just standard. It should be essential because this is really the only way we're going to be able to hold somebody if they go in and you weren't expecting it. So moose knuckles are one of the new things we've sort of brought in, and they're a great idea. Let's see, I think on the next page I've got a picture of one. Nope. Anyways, for basic crevasse rescue, to use a simple system, you need to know how to tie an overhand, a prusik, which is a hitch, and a moose knuckle, which is a variation of the overhand knot. So it's really simple. We're not trying to use any more knots than are absolutely essential. Again, because at the end of the day, when you're cold and tired and disaster strikes, you don't want to be trying to remember how to tie some strange knot that you learned 3 years ago. This is a much simpler concept. Okay, that's a moose knuckle. Basically, you take an overhand knot, then you loosen the knot and you push the rope around the loop and you feed it through one of the bends in the overhand knot, you tighten it up, and what that does is it just creates a fat knot on all sides so that as it goes through the snow, the larger surface area binds and holds you beautifully. Okay, so that's pretty much where we are. It works. Everyone still with me? Make sense? Okay. So these are really complex knots we're working with. Here's the overhand. Remember this? It's probably the first knot you learned as a child. Just make a loop, feed it through the hole. Good. And a moose knuckle is just a very minor variation of that. Okay, that's the overhand knot. And then the prusik. The prusik is the hitch we all love to hate. It is kind of a finicky hitch. It's a little difficult to keep it aligned. And there are other hitches that are far more efficient and easier to tie, but the nice thing about a prusik is it will work in both directions. It is very reliable, it does not require any other equipment, and it's easy to see once you've cleaned it up whether or not you've tied it properly. So absolutely, if you know other systems and you like them and they work well, by all means use them. However, what I teach is the prusik for the simple reason is that it is always reliable, it works in both directions, and it works in all situations where you need to do a load transfer. It's the only one that does all of those. So it's just got all your bases covered. There we go. So basically it's just a girth hitch with 2 more wraps on it. And a standard prusik is 3 wraps. If you need more wraps, put more wraps on. And the prusik needs to be the same diameter or less than the main line you're tying onto. Ideally less. But you know, in a pinch, you can make it work on the same diameter. And the nice thing about it is they slide, then as you load them, they bite. Prusiks have huge advantages over mechanical systems in that when you exceed their strength, they don't damage the rope. They just slowly start to slide down. So you're not damaging the rope, and as soon as the excess stress is released, the prusik bites again. If you use the rope men, the T-blocks, various sorts of mechanical ascenders, they all have teeth. And as soon as you reach a force at or above around 4 kilonewtons, which is roughly 400 kilograms, it starts to shear the sheath off the climbing rope and damages the rope. It's not a catastrophic failure, but it's a problem and you've ruined your rope. So you're not going to use it after that event. Whereas the prusiks, they always work. They don't always work, but when they slip, they're not damaging to your main climbing line. So again, they have some advantages. In that sense, they're not as fast, they're not as smooth as the mechanical systems, but they do less damage to the rope. Okay. So in terms of the basic equipment that we recommend you carry on a Glacier, moose knot that is this similar to a butterfly? The moose knuckle is not similar to a butterfly. It's not an adjustable knot like the butterfly. People have talked about using butterfly knots for tying in between members on a rope, and that might be applicable. The reason we choose the moose knot is because it wraps around very nicely and just gives us a bigger mass. So there's more surface area and it bites into the snow better. So that's our justification. I'm trying to remember what they used in Europe, but it's escaped me right now. So yeah, it's the same idea, but I think within our organization, the ACMG, they've chosen the moose knuckle as their standard. Okay, so for equipment, once you know your knots and you got the ropes straightened out, you're going to need a few toys. Make sure you have a shovel, and you should only carry a metal shovel. Yep, they're a little heavier, but they're stronger and they're very reliable. You're going to need 2 spare locking carabiners. So when you tie yourself into the climbing rope, most people will use carabiners, and that works great. There is a triple action carabiner that keeps the rope separated so as not to cause cross-loading on your carabiner. Those are now considered reasonable for Glacier travel. Standard locking carabiners may be an issue because if you catch them sideways, you're pulling on the weak part of the carabiner. And you can also tie in, but I'm not going into that tonight because it requires learning a new knot, which is kind of weird, and that's just not where I'm going tonight. Keeping it simple. But there are options. So you're going to need that. But in addition to what you need to tie or clip into, you're going to need at least 2 extra carabiners, and those 2 need to be lockers. Then you should carry some cord. And sort of the standard is to carry 2 7mm, 5-meter long static climbing cords. You don't have to carry that. If you want to carry a high strength 6mm, that's fine. If you want to carry the 1 ultra long sewn sling, I think they're good to 1,500 kilograms, that's fine too. But it's a good idea to have one of them as a 5-meter, 7mm prusik cord, just because they make nice prusiks and they will stick to all the standard climbing ropes. Again, there is a 6mm rope that is suitable for glacier travel now. It's kind of a specialized system. It's much lighter. It's very strong, but it has special concerns and it requires special rescue systems because it's not quite as simple and the rope is so much thinner. You're going to need better capture systems or smaller prusik. Okay. It's good to have an ice screw. One person, everyone should carry an ice screw because if you fall in the crevasse, you can use it to anchor yourself. If you're the second on the rope, you can use it to put in an anchor if the snow is not very deep. And as a third, you can bring that screw up and you can put it in as a backup to help protect the one screw when you approach the second. Okay. And you're going to need that extra rope. So that's why we did 6 pulls before we tied the first knot on the climbing rope. You want 12 meters at the front and 12 meters at the back so the leaders can switch positions. If you're not going to switch positions, then you might be able to put the rope just in the back person and keep the front end a little lighter. But remember, if the back person goes in, you don't have any extra line and the front person's braking for the whole day. So that's the absolute minimum you need. You can add to that by all means, but don't carry anything less. And depending on what I'm doing, that's sort of the minimum I carry. When I'm out, I'm almost always carrying more because as a guide, I have to be prepared for the fact that the rest of my group might have nothing. So I need a few extra toys. But when you're out with friends, or if I'm just out with friends, that's what I carry. Somebody falls into a crevasse, it's pretty straightforward. First thing you got to do is arrest the fall. You got to stop them or you're all going in. And for that, really, if you're a party of 3, the first person falls in and the second person should just fall over and try and fall sideways. And then the third person will just back up, take the hit, and hold the weight. So the first person falls, the second person is the shock absorber and becomes sort of the braking device, and the third person just backs up, takes attention, and becomes the anchor. So it's number 2 who's really going to go for a ride. This kind of brings me to something I haven't mentioned before, harnesses. The only harness you should use on a glacier is a sit harness, classic sit harness. And the reason for that is if you have a sit harness with a chest harness built into it and you fall into a crevasse, the chest harness is basically the rope feeds through it and it's dynamic. And so as you fall in, you're not going to hang upside down, you're going to be straight up and down. And when you hit, your spine is going to compress. And when your spine compresses, you run a really high risk of blowing spinal discs and suffering serious back injury. If you have a full body harness and you tie into that, that's fine if you're the person who falls in. But it's not so good if you're the second. The second should also have a sit harness because if they have a chest harness or if they have a full body harness, their center of gravity is higher and they're going to be dragged face forward towards the crevasse. Whereas what you really want to do is just sort of spread out perpendicular, create as much resistance as possible, and stop the fall. So every position should be a sit harness. And yes, if you're wearing a pack, even if you're not, when you go into the crevasse, you're going to be hanging upside down. And I've done that. It's really scary. Don't sweat it. If you're hanging upside down, looking into the black, as soon as you calm down, you can just think to yourself, hey, it really did work, because it worked. That's really the key. And I'll talk about that in a minute, about how to deal with it if you're in the slot. So there's a question about what thickness of rope do I use for crevasses. As I mentioned, there's a specialized 6mm rope. The Radline and Spectra can be used, but they're expensive, and they really can only be used for glacier travel. If you want to take a half rope, which is like a 7.8, right up to 10 or 11mm rope, those are fine, and they're suitable for multiple applications. They're also dynamic ropes, and so they stretch. The 6mm is static, so if you took that thing climbing and you took a leader fall, it would break you because there's absolutely no absorption once you hit the end of the rope. There's no stretch, and there'd be a lot less play dynamically through the blade device. So basically 7.5 mil and higher is fine for the climbing rope. And again, if you're really going lightweight, the 6mm is fine, but you're going to need to learn some new systems because it's a little different. Okay, In winter, with good snow depth, would a dead man be an option for an ice screw? You know what? In winter, if you've got good snow depth, I'll show you what I'd use. Because the next step after you arrest the fall is you build an anchor. Oh, I just talked about arrest the fall. Sorry. Like I said, I'm in the process of building this book, and I've trimmed it down because there's a lot in here I can't do in an hour. But I'll show you my favorite anchor. If you're out ski touring, which is what most of us are doing in the winter, build your anchor with skis. And so I'm not tied to a rope here, but this is how you build the anchor. Measure the distance across, then take your shovel, and you dig out the depth you're going to need, or sorry, the length you need for your skis. Now when you're digging that out, this is the second on the rope. So they're actually kind of got the third, which is holding the weight, and the first, which is in the crevasse. So you're not going to go for a walk. At best, you're on your knees and you're digging this out. So it's a little tricky. You want to pad the edges of the skis if you can, because you're going to be putting basically your anchor rope around the metal edges of your skis, and there's a risk of cutting. Now, in terms of how deep do you bury it, it's going to depend on the strength of your snow. If you've taken an avalanche course and you've heard us talk about snow density, we say you want 1 finger snow. And what that means is when you push one gloved finger into the snow, you start to feel resistant at your wrist. The problem with that is at the soft end of feeling resistance at your wrist, a pair of skis is just barely enough to provide you with a basic anchor. So try and get snow that's got a little more resistance than just that. And then if you do, you bury your skis down deep. I'd recommend at least 1/2 meter. Try not to disturb the snow from the direction of the pull. Cut a T-slot, bury it, and that anchor, to be honest, we don't know how strong they are. We haven't actually done any tests. So this spring, I'm going to grab some of my old skis. I'm going to put a scale on them, bury them by the road, and I'm literally going to attach them to the car and just start pulling with the scale until it rips out. But we do know they can hold over 7 kilonewtons if they're done well. We don't know how much more. 7 kilonewtons for a snow anchor is really good. Okay, it's not the same kind of standards that you use in other industries, but it's more than enough for 2 people hanging on a rope. So there you go. There's your anchor. Make sure you minimize the load-bearing wall, the damage to it. Bury your skis well, and there's your master point. Again, you can use a sling there, and just do a couple of wraps around the skis. When I tied it, I tied a clove hitch. We've since changed that standard because clove hitches will weaken the strength of the rope by 1/2, which is huge. Whereas if you just throw a couple of wraps around the skis, 0 loss. So as long as the edges are padded, you can have the full strength of whatever your material is. So that's pretty good. All right. So that works pretty well. And like I said, everyone's got skis. If you don't have skis, or your skis just don't seem to be strong enough and you can't get down for an ice screw, you know what? Bury your skis and then bury your pack. Pack also has a lot of surface area. Put a wrap and attach your pack in there as well. There's all sorts of things you can use for snow anchors. Again, while I was doing this research, I found an article where they were testing snow pickets, various devices, and then they were trying compromised systems, and they were even doing Coke bottles filled with liquid, clove hitched, and then buried in the snow. You don't want to risk your life with that. But they held better than I thought. In a real pinch, you can even do things like stuff sacks. Fill them full of snow, clove hitch them, bury them deep, bury them well. Have a backup because you don't want to see if they're going to blow or not. But if you had to leave a snow anchor behind because you're doing a rappel on a big ski tour, or you got hung up on cliffs while you're skiing and you've got no other anchors, those are possible emergency anchors you can look at. But remember, you've got a life at the other end, and snow is not the most durable material. So yeah, I might just leave my pack behind and take the loss as opposed to start filling snow with stuff sacks. But, you know, it is an option if you're really desperate. Don't ever get in a situation where you're really desperate. All right, so then you transfer the load, and that's where you use a prusik, and you put it on the loaded rope where the victim fell into, and then you can attach the prusik to your anchor. Again, I've got videos coming to show you what that looks like. Once you've done that, you can tie the rope, the climbing rope, into the anchor because the third can move up. You get some slack, tie an overhand knot, and just clip that into the anchor as well. Boom, you've used your 2 carabiners. And now the person who fell into crevasse is being held by your snow anchor. The third then moves safely up, and you can assess the situation. So they're going to work their way, either belayed or prusicking, towards the edge of the crevasse, look over, make contact with the person, and decide what the best course of action is. Now, once upon a time, we used to say maybe you could pull somebody up by the rope they fell into. And this was always a pretty marginal, kind of a bad idea, because the rope they fell into has cut into the snow and is going to have huge amounts of friction. And so we've always encouraged people to have the rescue rope so that they could drop down some rope, and we could put the rope on top of a pack, and that way it doesn't cut into the lip of the crevasse. Make sure you take a shovel, dig out the lip so they actually have room to get out of the crevasse, and it reduces friction. We've learned that friction is the biggest problem with crevasse rescue. And so by taking your pack and putting the ropes up above the snow so they don't drag through the snow, and there's very little contact as it rolls over the edge and goes into the crevasse, there's a lot less friction. And that is huge. If you don't do that, you have a serious probability of creating so much resistance trying to get them out that you can't. So be careful, have a rescue rope, and make sure you use a drop loop, which is actually a full loop going down and back up. You can do that because if you take all the rope that the third brings to them plus the rescue rope in their pack, so long as they untie all their moose knuckles, you've got plenty of rope to create a loop, get back, and pull them out using a loop, which creates a 2-to-1 ratio. And for 2 people to do that, you're in pretty good shape. Because basically you've got the equivalent force of 4 people pulling one out, because 2 people on a 2-to-1 creates a 4-to-1. And there's relatively little friction in the system. So that's pretty good. And don't worry, don't get too hung up on all the math and the extrications, because I'm not going into that tonight. It's very easy to start getting overwhelmed, and I can't do it in a simple, clean manner within the scope of this presentation. There just isn't time. So basically, you're going to have to now extricate them. And you're going to use your anchor, and you're going to use a clean rope so that you don't have to worry about the moose knuckles. Because now that we've put moose knuckles in the rope, it is impossible to winch somebody out of a crevasse on the rope they fell into if they have moose knuckles. Because not only are you trying to get the person out, but you're fighting all the friction created by those knuckles, which made it easier to stop them when they fell in. So you can see the problem. Yeah, I will have a diagram, I'll have a functional illustration, but I just don't have one ready at this point. So the whole thing will be there, it will be animated, but I can't believe how stupidly busy I've been during the pandemic, because every course takes 3 or 4 times longer than expected to create the new material and all the other systems we have to do, and the delivery methods and keeping track of everyone. It's been too much. So this book has kind of been sitting on the shelf for the last couple of months, although I was working pretty hard on it over the summer. So when we use more complex systems, then we start using the capture devices. And this is probably what you're all familiar with. Things like the Garda hitch. It's actually a really nice system because it only requires 2 carabiners and a little bit of cord. And what it is it's a ratchet. You can pull the rope one way and you let go and it locks. So it helps you pull somebody up. Sounds like a great idea. It's so-so. Then you can buy these devices like the air traffic controller or the Black Diamond guide. And they have a setting in which basically they'll do the same thing. You clip a carabiner through it, hang it off another carabiner. The rope will slide one way and locks when you let go. So those are ratchets. They allow you to pull things up. You can do this with a T-block. A lot of people don't realize this, but T-blocks actually make a pretty good ratchet. Very simple little device. And they pull and they lock. You want to be careful because it's easy to get confused and do it the wrong way. Once you do it right, you know exactly what you've done and you feel like it's right. Okay. And then There's also basically a prusik-minded belay device. These work pretty well. You basically tie a prusik, and so as they get pulled up through the rope, the belay device keeps the prusik from jamming onto the carabiner. When you let go, the prusik slides down and it locks. It works pretty well. And then, this is my favorite, the prusik-minded pulley. So you pull the pulley, the rope feeds the prusik to it, the prusik is stopped, the rope slides through, and then when you let go, it binds and it holds. And then this is the one everyone runs out to buy. Whether it's the Sprock or the micro traction, basically it's like a T-block on the side. It's a cam device. You pull one direction, it locks and holds the other. These are very popular, and the bearings on these pulleys are very efficient, and so it tends to be one of the easier systems out there. Okay, and again, this is just going into some other things. And there's a question after capital wraps, would you add a mule hitch or something similar? I'm not fully sure what the question's referring to, but yes, you can do an overhand knot, do an overhand as a tie-off, and then tie off the overhand so that it can't, the overhand slip knot can't slip. But here's something I do want to go into. When you start looking at getting into mechanical systems, more than just a loop, be careful, because things are not as they appear. And this is big. So again, I had lots of time during the pandemic for a while. I started hanging some systems off the roof, or off the ceiling in the garage, and I began pulling the forces to see what they were actually doing. So here's a really simple system. So imagine we're going to build an anchor. This is our anchor. We drop the loop down and we pull the victim up. Okay, on a 2-to-1, this is a 25-pound weight. It should weigh 12.5s. Running over the carabiner was 17.6. Running it off a high efficiency pulley, it was 15.6 pounds. So there's a loss with both. And the pulley was 80% efficient, and a carabiner was 71% efficient. But it doesn't stay that way. If you add more weight, the pulley doesn't change too much in its efficiency, but the carabiner becomes increasingly less efficient, almost to the point where the carabiner is about 50% efficient when I was pulling 100 pounds. And so if you have a pulley, that will make a huge difference in the amount of force it takes to pull somebody up. Because let's take a look at your next nightmare. Oh yeah, I don't have this. So rope capture efficiencies. This one was terrifying. So you look at the Garda, which is the ratchet that we all sort of learn. Oh, I started with this one. So the ATC. In order to pull 25 pounds, I had to apply a force of over 150 pounds in order to lift that thing. So that's a complete waste of energy. The Garda was no different. 25 pounds, I had to increase a force of 140 pounds, a 560% increase in force. Okay, now the prusik-minded belay device generated a force of just over double, because that's when we're dealing with this pulley again, or sorry, the carabiner. And so it almost doubles the force I have to actually pull. The T-block was a little bit better, but not too far off. Working with a prusik-minded pulley was a lot better. And it was only became 36 pounds to lift 25. The Sprock and the micro traction are really about the same. And it came up at 20, it just came up at 28 pounds, so pretty close. These numbers really indicate that your systems, your capture systems are huge. And your prusik, your T-block, prusik-minded pulley, and especially the mechanical rope capture and the prusik-minded pulley were your best systems for capture. However, things changed. I did this same test, and I haven't produced the video yet, where I was pulling 100 pounds, so almost 50 kilos. And when I did that, the prusik-minded pulley was more efficient than the Sprock or the micro traction by just a pound or two. And so keep in mind, those are good systems, but when you read the labels that say they're 90% efficient, they're 90% efficient on a certain load. And as the load increases, some systems become less and less effective. And the prusik-minded pulley did really well. That is my choice. That is what I use for progress capture for crevasse rescue, because the pulley costs a lot less and it's very versatile. Also, everyone in the party can have a pulley. They're not very expensive. So if you lose one, you've got a backup there. And if you've got extras, you can start putting them in more points for when you try to do a rescue. So that's really significant. The other thing that was kind of interesting is, again, I can't remember if I did this or not. I may not have pulled this in. Let me see. No, I didn't. When I started creating crevasse rescue with a greater mechanical advantage, so I'm planning on, lifting more and more weight without working as hard, the efficiency decreased dramatically. And that was not good. But because I was now having a pull coming in ahead of the Garda and the ATC system, they became about 50% efficient. So they became much better. And they were about as good as the T-block or no, they weren't quite as good, but they were getting a lot closer to the T-block or the prusik-minded belay device. And so that was hopeful. It was interesting. Those actually became reasonable for more complex systems when you had a lot of weight. So again, I'm not going to go into those too much. I can't do that in an hour. But the real take-home message here is that things are not as we thought they were. Mechanical advantages, if you use pulleys and you do everything right, just the friction in the system. When you create a mechanical advantage, that's 6 to 1. So basically that means if I pull with a force of 1 Newton or 1 kilogram, I can lift 6 Newtons or 6 kilograms. 6 to 1. Drop loop is 2 to 1. But a 6 to 1 ratio done as efficiently as possible with a standard climbing rope will give you an actual advantage of 3 to 1 because the friction takes about half of it. And if you're just using carabiners and not pulleys, it's going to be 2 to 1. A 6 to 1 advantage becomes a 2 to 1 advantage after the friction. And that doesn't include anything that's dragging through the snow, which is why it's so important to get your pack there and have the ropes above the snow, because it's taking away everything you work so hard to gain. And those were the really important things, is learn to do these systems, because if you're just 2 on a rope, 2 people in total, 1 person's got to do all the work, you're looking at a 6 to 1 or a 12 to 1 mechanical advantage to get them out. And you're going to need to maximize your efficiencies, or they're going to be too hard to get out. Bummer, dude. All right, so let's go to something that you're probably a little more familiar with. If you fall into the crevasse, life is bad. But it's really kind of the same process as if you're on the surface. You need to arrest the fall and build an anchor. So if you fell in the crevasse, there's not much you can do to arrest the fall, but you can build an anchor. So if you're quite a bit heavier than the other people and the rope just keeps slipping, what I would suggest is you're going to need to put an anchor into the ice and clip into it. Because if they keep slipping, then that anchor is going to hold you, and the people on the surface won't have to hold your weight, and they can start to build the anchor and deal with it. This actually happened to a friend of mine. He fell into a crevasse, and he had a large pack, and there was just one other person on the rope, and the person on the surface had a chest harness. And so he was being pulled face first straight towards the crevasse, and he could slow things down, but he could not stop the fall. And the individual in the crevasse realized that the guy on the surface wasn't going to stop, and he started threading an ice screw as low as he could go and kept threading it. So as the ice screw just kept going up and past him, he just clipped the carabiner onto the shaft of the ice screw and had the other end clipped into his harness, and it held. And then he finished threading the screw in. That's a really good idea. And even more importantly, put 3 on a rope and don't use a chest harness. Okay. And then, the cable transfers the load. You assess the situation and you can follow through. There's a few things you can do if you're sitting in a crevasse. And this is me hanging in a crevasse. Actually, I was hanging off my garage with a green screen. So the first thing you got to do is take a carabiner and clip your ski poles onto the rope, so your hands are free. Next, you're constantly fighting because you got a pack on your back. Take a carabiner, clip it onto your pack, or take a sling and clip it onto your pack so you don't drop it into the crevasse. Clip your pack on. Now you're comfortable. You can sit back and you can wait. If you need to, put that ice screw in and then clip a sling onto it, clip it into your harness, and you're secure. If you know your team is strong, you don't need to do that. When the rescuer comes and drops a loop, give them your pack. And it's gone. Once the pack is gone, take another cord out, turn it into a loop, or just grab a loop. Have a little bit of cord on your skis tied to your binding so that you can clip a carabiner on, take your ski off, and even if you drop it, it's not in the crevasse. Clip it on again, take it off. Wrap them up. Take your ski poles, wrap them around, and then it's not a bad idea just to have a strap. I have a little ski strap that I carry with me. Bundle up your skis and your poles. Then when the loop comes down, just clip that cord on and it all gets pulled up. And now you're lighter for them to pull up. You're also in a position to start prussicking. So yeah, this is the classic idea of prussicking out of a crevasse. It's a great idea, except when it's not. Because remember, you've got moose knuckles. So now you're going to prussic up that rope and you're going to come to a knot. And that is going to make your life absolutely miserable. Yes, I was playing with this. There is a way to get over the knots. But you know what? It's fairly complicated. I'm not going to go in it tonight. So understand the other issue with moose knuckles is self-rescue becomes much more difficult and you're going to need to practice it. Because what you do is you literally prussic up to the first moose knuckle, then you take all that slack in the rope, take a carabiner, a locker, and basically clip it into your harness so you're hanging off the rope again. Then you slack off your prussics and you tie them above the first moose knuckle, and then you put them right back on the way you did before. Stand up in them, unclip from the climbing rope, free your carabiner, put it back on your harness, and then prussic up past that next moose knuckle. It can be done. It's a lot of work. But the big thing is the people on the surface can hold you so much better than they could before. And so that is what I have in terms of what's coming down the pipe for some of the new standards for crevasse rescue. The biggest things we've learned is put some knots in your rope. And as I said, by all means, look up the French research, crevasse rescue using knots. Probably you will pull it up on YouTube. And understand that we're going to need to use a second rope to get the person out. And by far the most energy efficient way to do that is going to be with a drop loop system, a pack on top, and have everything above the height of the snow with the edge nicely cleared. And then be careful with your capture devices. In a pinch, yes, you can use something as simple as a Garda, so long as you're using a more advanced rescue system like a 6-to-1. If you're just using a 2-to-1, it's worse than nothing. In fact, what I usually use are prussics. For a 2-to-1, we just have a prussic, we pull, we slide the prussic, we let go. We pull, slide the prussic, we let go. The other end is tied into the other end of the climbing rope is tied into the anchor, so even if the prussic slips, they can't fall anywhere. And when we get the slack, we just tie it off, and that way they can only slip to whatever rope we have tied off. Again, that's a bit much for to go over tonight. But use pulleys. Pulleys make a huge difference, and the more the mechanical systems designed for it, the traction and the sprock, they work fine. The biggest limitation of them is as soon as you reach loads of 4 kilonewtons or more, which is around 400 kilograms, those devices will begin to tear the rope and they will damage it. They will not destroy it, but the rope will not be usable after the rescue because they have teeth. It doesn't matter which system you use. Any of the cams with teeth fail, at around 4 kilonewtons plus or minus a little bit. Prussics don't fail like that. They just slowly begin to slip, and when the excess load has been compensated for, they bite again. So that's my preference. I'm using a prussic mounted pulley, and as I said, with big real world loads, they are just as efficient, or depending on how you want to cut your hairs, maybe even a tiny bit more efficient than a heavily loaded sprock or microtraction. That's just on the numbers I've pulled, but they're good. They work really well. The pulleys need to be at the rescuer's end. So the first bend that the rescuer has to deal with, pulley. Then the next closest bend, pulley. The last, and you keep working that way down until the last time you use a pulley is at the victim. So you get your best mechanical advantage and the least friction if the pulleys start basically from where the rescuer is holding the rope and just look down to each bend in the system. And that is backwards from what I was trained 15, 20 years ago. So we've discovered that difference too. So in a nutshell, these are sort of the new guidelines we're coming up with. And as I said, this will be all put together in a book as soon as I have some time, which I'm hoping to do in the next few weeks, but it's been crazy. If you want to, take down my email, I'm happy to let you know if and when I have more information completed and it's available. But otherwise, if you have any questions about this, by all means, feel free to get in touch with me. Again, my email, I think it's on the screen, dougklatimer@gmail.com, and I'm happy to answer any questions you have. What do we have here? Curious what your opinion is in terms of placement of team members and in a line or staggered on the way up versus the way down. Ideally, in terms of placement of your team, if there are 3 people, remember the second person's going to take the hit and they're going to get, really trashed. So you want somebody solid in the middle. The person up front, you can put the lightest person up front, but they might be able to get over a crevasse and then the next heavier person punch through. And somebody in the middle of the rope is a whole different beast on how to get them out. Can be done, but it actually becomes a lot more similar to as if it's just a 2-person on the rope team and 1-person rescue. If you're able to travel perpendicular to the crevasses, then just traveling in a straight line is great. It's also the most efficient. If you know you're in an area where the crevasses, you're running parallel with the crevasses, you may want to stagger in kind of a W pattern so that one person is off to side and then the other people are not skiing on exactly the same spot. So you're not all sort of skiing into the same hole parallel to it. Or you can just, move your team so you're a line. Each person is breaking their trail and you're just going sort of like a line up against the direction of travel. That can work too. But most of the time we travel one behind the other because we don't know any better and we just don't know what the crevasses are doing. So it does get to be a bit tricky. In terms of weight placement, I like to have somebody sort of similar mass to me behind me, or maybe a little bit heavier, because, then it's not so hard on them. When I traveled with my family, my spouse is quite a bit lighter than me, and our son at the time was 12, so he had no weight. And basically I wouldn't travel unless we had a team of 4 because I didn't think they had enough weight. And I put the heavier person right behind me, and then my spouse and then my son and my spouse in that order, just so that the shock absorber was somebody who was a bit more durable to take the kind of hit that I would generate. So I hope that answers the question. And learning to ski. If you use moose knuckles, when you will be limited to using a drop loop or 6-to-1, in your experience, would that ever cause problems with enough rope remaining for rescue? If you're a party of 3 and you use a 60-meter rope, you have enough rope to do the drop loop and to do a 6-to-1 and to do a 12-to-1. If you use a 50-meter rope, you don't. Not in winter. In summer, you would just have enough. But in winter, a 60-meter rope works beautifully. And that's also a standard rope for climbing. So if you buy just one rope for all your mountaineering activities, whether it's, sport climbing, multi-pitch, mountaineering, ski mountaineering, and ski touring, just a single 10-millimeter rope will work beautifully if it's 60 meters long. There are specialty ropes, as I said, but you know what? A 30-meter specialty rope costs more than a 10-millimeter standard climbing rope, and they're only applicable for ski touring. The 40 meters, even more expensive. Yes, a 3-person team can use a 40, but only one person's going to have the extra rope. There are other ways to compensate for that. They start getting fairly complex because you're going to have to build multiple anchors and move and transfer the load to create enough rope to get somebody out. So you'd better know what you were doing if you're going to start using just 30 meters of rope. And for 2 people on a rope, it actually takes more than 3 because they don't line up in the middle of the rope. And so in order for them to have enough rope, they each need to have a loop with them. And so 2 people on a rope require more rope than 3 people on a rope. And I can't remember my numbers, but I think 2 on a rope can get by with these standards and with moose knuckles with a 60-meter rope. And just go figure, eh? So it is tricky, but a 60-meter rope is magic. It does it all. And then just go with, a 10-millimeter rope or a 9.8, and it'll serve you in many ways. The one thing that is nice to get is get a dry line so that in summer or spring, when you're traveling on the glacier, the rope doesn't become saturated. It does not affect the strength or the quality of the rope, but it does get heavier. And so you're just carrying all that wet rope with you. Any other questions? That's what I had for this evening. Okay, we've practiced with real loads in the snow with prussiks, pulley, and found that the prussik is often not minded. We always need a person minding it. Any suggestions? Is it a prussik pulley? One thing to check is, are you using a prussik specifically designed, are you using a pulley specifically designed to mind a prussik? Because a standard pulley won't work. You have to use something called a prussic-minded pulley, which just has a couple of metal flanges on it. And if you're going to spend the money on that, because they charge you $10 more for another 20 cents, it's a prussic-minded pulley. Okay. I just asked because people don't do that sometimes. Play around with it, because I've had really good luck with real loads and using a prussic-minded pulley. If you don't trust it, then by all means, look at the micro traction or the sprock. They're very reliable. It could be that you're working with a smaller diameter rope and a smaller diameter prussic, and the pulley's not designed to catch it. You might not have enough wraps. We recommend 3 wraps for the prussic-minded pulley. If they're close or the prussic is made of a really stiff rope, it may not work. There's another material you can use. It's called Auto Block. It's really soft. It bites very, very nicely. It's very reliable. But it's a bit of a specialty material, and you may have to tie it off to shorten it so that it works well as a prussic-minded material. And yeah, no, actually it should work straight as a prussic. So try that, but to be honest, I'm sorry, I don't know exactly what the problem is. It may be something I'm just not aware of. Yeah. A friend of mine actually had some pulleys custom made for him, and he gave me one, and it's really tiny, and it's worked surprisingly well as a prussic-minded pulley. So yeah, I think it may just be the design. Okay. Any other questions? Is a single meter stand of double rope enough? Yeah, usually. I mean, double ropes usually start at 7.5 or 7.8. Yes, they're fine. And they do work. And I think what I travel with is an 8.5. My 60 meters are 8.5s. But you have to remember, when you take a fall in crevasse, into a crevasse, it's a very soft fall. There's not a lot of energy generated, so you don't need a really strong rope. And also, it's really soft on the victim. Like the person falling in the crevasse really doesn't feel anything. It's just like, oh, hey, it really works. Meanwhile, the second is like, oh, it hurts, I'm being dragged. The rope itself isn't taking huge impact force. Yeah. So yeah, it probably is. And I'm just trying to remember. I remember for years, Barry Blanchard used to climb on twin 7mm ropes. And I just can't remember if a 7mm standard Purlon is considered strong enough for for Crevasse, for Glacier travel. So I'm just can't answer that. Hey, Dave, how you doing? I'm going to get that material to you, but I've just been so slammed that I haven't had time to finish it up. But thanks for joining. Okay, yeah, thanks, Mark. And thanks, Nico. Where can we get more information on the new standards now while you're writing the book? That's why I'm writing the book. We don't have any source to deliver the standards. In fact, within my association, the manual dates back to 1996, and they're in the process of updating it, but it could be 6 months to a year before we get that. I'm trying to produce a national standard through the ACC, and this is the book I'm trying to write them into. So I'm sorry, I don't know where you would get more information. Petzl has a really good website, and they have some material in there on standards. Most of that information is very good. A couple of things we do a little bit differently, but overall the Petzl PDFs on crevasse rescue work really well. I think it's also in ski mountaineering. What else? Will this be available to watch going forward? I think so. I think these have been getting recorded and people are watching them afterwards. I said the standard came out of France. Well, they tested it in France. Where it was created, I don't know. It is European. But the French were the first people to actually test the concept of using knots in the rope to increase friction. And, it was a proper scientific study, and they did it well. Unfortunately, I don't think they actually wrote a paper up. I've seen the video, but I can't find the actual research paper that I would hope they would write. Okay. Yeah. My pleasure, guys. Thank you. Hopefully we'll see you in the mountains. And it rained yesterday, but today in Canmore we got snow. So definitely check the avalanche bulletin if you've been following the snowpack. The world just changed, and it changed in a big way. I think for the short term, it's going to be better. For the long term, I'm not sure yet. Yeah. So yeah, hopefully we get enough snow that we can start skiing on glaciers comfortably. This is kind of that spooky time when it's like, oh, there's enough snow to go, but is there enough snow to hold us? Put the rope on. So yeah, thanks guys. Take care. And I'm going to go have some dinner. Take care. Thanks very much, and I'm going to end the stream. Oh, and by the way, yeah, if you do have questions, by all means, write down my email. You can send me a question. If you want, I can, let you know when I have these standards written up. Oh, cheers from Hawaii. Oh, I am so jealous. We went to the Big Island just before the pandemic broke, and we're so grateful we did. We just love the Big Island. We went up and watched it was a moonless night, and we drove up to the viewpoint on Mauna Kea, and that was, I think, the highlight of the whole trip. Is the French video with the knots? Yes, it is. And yeah, in fact, if you want to write down my email address, I'm going to have to look it up anyways, and I can send you the links. All right. So take care, guys. Have a good evening. I'm going to see if I can figure out how to shut this off now. Have a good night. See you next week.